All right, good afternoon, everyone. So for those who just came in the middle of the video, I played for the class this YouTube video. It's a TED video entitled "The Greatest Mathematician That Never Lived" by Pratik Agor. And this is a nice story about this made-up mathematician named Nicholas Bourbaki. But the revolutionary thing about his work is that sila yung nagbigay ng common ground among all branches of mathematics. Because prior to them, parang pag meron kang isang expert sa algebra, tas meron kang isang expert sa analysis, there's very little chance that these two guys can collaborate with each other because essentially they are using different methodology. It's as if they are using different languages, even if parehas na mathematical yung pinag-aaralan nila. So even if they have an axiomatic system, iba-iba yung axioms nila, pero yung language sa mga sa mga sub-disciplines na pinaggagalawan nila ay magkakaiba-iba, making collaboration very much difficult. All right? But with the onset of Verbaki, one of the things before yung konsepto ng functions na highlight dun sa video, there is they actually created the you can think of it as the unifying framework or unifying template among all mathematics. Tapos yung idea na yon ay yung set theory. So they revolutionized how functional analysis, how real analysis, how algebra, how geometry is written now in terms of sets. Yung common notion ng sets na pinagtrabahuhan nila Cantor, ni Zermelo, ni Frankel, at saka ni Skolem. That's why it's very important for you guys to appreciate at least the rudiments of set theory. Kasi after you graduate from 101, pupunta na kayo sa mga major classes nyo, and you will see na almost in all of these classes, yung mga theorems, mga expressions, mga propositions, they're always phrased in the language of sets. Kaya nga, 'di ba, usually sa mga courses sa college, yung symbolic na number na 101, lagi siyang binibigay dun sa pinaka-fundamental na course. And for us, and even around the globe, yung Math 101, lagi siyang may kasamang set theory. Because if you will get an idea about set theory, you will be immersed into the language that transcends all disciplines of mathematics. So for those who missed out the video, you can just search it on YouTube. Makikita nyo naman siguro dito yung URL or yung title. So it's a nice watch, right? And then before we proceed to the formalities, some housekeeping matters. Worksheet 8 is moved. Kailan ko ba siya ni-move? Inilipat ko yung worksheet 8. Ang deadline niya na ay November 26. So that would be next Friday. Yung worksheet 8 kasi siya yung associated dito sa bagong worksheet na pag-aaralan natin starting today. And then I won't be able to finish it. Tapos medyo gahon na ako sa oras. So what I'll do is I tap your lab instructors to carry on the discussions in the lab classes on the lab classes on Monday. So if you want to keep a pace with the discussions, please pasok kayo if kaya nyo sa Monday sa inyong mga lab classes because they will continue my discussion. I'll discuss half of this study guide and they will carry on with the rest. Para pagbalik natin sa Wednesday, panibagong study guide na yung gagawin natin. So for this case, I am using study guide number, what number is this? Study guide 9, which contains worksheet 8. So ito yung gagawin natin. And then also another reminder, the second problem set would be on November 29th until December 1st. And then medyo ilang linggo na lang bago ang SEM break. I think after December 1, we'll have just 3 more weeks to go, but still 2 problem sets to finish. So medyo magiging tight na yung schedule natin from here on. So, but I will rely on your lab instructors to carry on the discussions. Kahit gustuin ko man na i-monopolize yung discussion, kailangan ko nang kunin yung tulong nila para hindi ko naman ibigay as a reading assignment yung mga importanteng bagay. So at least meron pa ring instructor na mag-guide sa inyo with these discussions. Okay? Now, this study guide is focused on defining or formalizing operations on sets. So last time na-define natin kung ano yung set, or actually hindi pala natin siya dinefine formally kasi sabi natin ang isang set ay undefined term. It's just a collection of objects called elements, which by the way is another undefined term. And then, tiningnan natin paano inimbento ni Cantor yung early set theory, but there was a contradiction put forth by by Bertrand Russell. And after the discovery of Russell's paradox, here comes Zermelo Fraenkel and Skolem, who tried to fix set theory and save the day. So, yung set theory na ginagalawan natin ngayon ay yung modern set theory na, which is the Zermelo Fraenkel set theory, but it retained all the nice properties of Cantorian set theory. So ngayon, pupunta tayo sa susunod na level, which is how do we play around sets? Ano yung mga operations na pwede natin gawin sa mga sets? I'll try to cover three of them: the union, intersection, and difference of two sets. Okay? Have you guys seen this before? I think sa Math 19 or Math 20, you already encountered set operations. Tama ba? Or yung iba sa GenMat yata nakita na to before, especially if you went on STEM track nung senior high. Tama ba? Bakit walang sumasagot? Hello, guys. You can hear me right though. Tama ba? Parang uncharacteristically tahimik kayo kahit sa mga pa-reacts or sa chat box. But I hope you can hear me well. Okay? May party kasi dito sa bahay, so nagsimula na sila mag-video. Okay, so I hope my voice overpowers their singing. Okay. But just let me know if something is not clear, or if my audio is not good. Okay. So let's start. Let's talk about the union of two sets. So we take two sets A and B. So ang union ng set A and B. Okay. Yeah. Thank you, Priscilla. Nagre-react pala kayo, though hindi ko nga siya nakikita sa screen. So thank you. All right. How do we fix this? Oh, let's just let it be. All right. So at least alam ko na nandyan kayo. All right. So yeah, ang union ay isang binary operation on sets. Ang tawag natin sa kanya ay binary kasi para mag-take ng union, merong at least dalawang sets na pinag-ooperate. Okay? So the union of two sets A and B is denoted by this symbol, red A union B. So the union is represented by this cup-looking symbol here. So it is the set of all x's which belong in either A or B or both. That's why ang formal definition ng union is it should be in the universal set. Ito yung ni-require ng Zermelo-Fraenkel Axiom 3 or the principle of schema of subsets. Dapat meron kang dalawang criteria para mag-belong sa isang set or mag-define ng isang set. Yung membership sa isang superset. Pangalawa, yung property P about X. Now, the property P about X that we will require to belong to the union is that dapat miyembro siya ng at least isa dun sa dalawang sets na pinag-union natin. And take note of the connective or. Okay? Or yung ginamit kasi dapat at least isa dun sa dalawang statements na to ay dapat totoo. Okay? So if you're gonna draw a Venn diagram to illustrate the union of two sets, halimbawa ito si set A, tapos halimbawa ito si set B, okay? Oops. Come on. Okay. Si set B. Kung gusto nyo kunin yung A union B, dapat ay kunin natin yung mga elements ni A, isama sila sa mga elements ni B kasi or yung connective. So itong mga shaded yellow, tapos yung mga shaded red, sinade ko lang yung buong A and B. And then the union would be the set containing those elements that are shaded at least once. So ang union nung set ay yung totality nung aking na-shade dito. So basically, parang pinagsasama-sama lang natin yung mga elements ni A and B. And hence the term union for this set. Okay? Now, before we proceed, just to give a quick example, sa limbawa sa example 3, ang set A natin ay yung set of the first four prime numbers, 2, 3, 5, and 7. And then B is the set of the first four positive even numbers. Okay? So if you're gonna take the union of A and B, kukunin ko lang lahat ng members ni A. Sure ako nasa union na sila. At saka yung mga members ni B, kasama rin sila dun sa union. But for instance, 2 is an element of A and 2 also appeared in B. In the union, si 2 mag-appear lang only once. Kasi sabi nga natin sa roster method ng pagde-describe ng isang set, every unique element must be represented only once. Okay? So here we have set A containing 4 elements, set B containing 4 elements, the union will contain 7. Kasi si 2 na common dun sa dalawang sets ay once lang natin i-represent. So basically, again, the union, we just collect the element of the two sets and put them together inside a set. Okay? So it's easy if we are just looking for the union of two finite sets. Madali lang siyang tingnan.
Decrease impulse.
Pero ang problema ay kapag ka infinite na yung number of elements dun sa set na kinoconsider natin. Alright? So for instance, in example 4, we have two infinite sets. The set of integers and the set of rational numbers. So if we take the union, kukunin lamang natin yung mga elements na nandito at mga elements na nandito. Alright? So if you can do it, if you are more of a visual person, maybe you can imagine or draw the Venn diagram for Z and Q to see ano yung union. Okay? So si Q, set of all rationals, sila yung mga kaya nating isulat as a ratio of two integers P over Q. Alright? Pero yung integers, yung mga integers, pwede natin silang isulat as that integer divided by 1. Tama? So ibig sabihin, lahat ng integers ay rationals din. So ibig sabihin, if I'll draw the Venn diagram for Z, dapat properly contained siya kay Q. Ano nga yung tawag natin kapag ganito yung itsura? What do we call Z relative to Q? Kaano-ano ni Z si Q? Tandaan nyo ba yung mga terms natin last time? Oh yes, Prince. Ano nga yung tawag sa kanila? Okay, I would guess kung anong isusulat ni Prince. Okay, tama. Z is a subset of Q, right? Kasi si Z, naninirahan siya sa loob ni Q. Lahat ng elements ni Z ay na kay Q at walang element si Z na wala kay Q. Pero parang parehas lang pala yon, right? But again, natutunan natin sa Venn diagrams, pag kinuha ko yung union, isa-shade ko lang yung buong Z, tapos isa-shade ko rin yung buong Q. Lahat ng na-shade ko at least once, sila yung mga members ng union. So here we see that the union of Z and Q is just the set Q. Kasi mula kay Q, wala nang madadagdag na iba. Kasi lahat ng mga posibleng idagdag ko ay yung mga integers, pero na kay Q na sila to begin with. Alright? So this gives us a nice idea to one property of pagiging ng union, and perhaps we will prove it later. Okay. Now off to some more elementary properties. Perhaps let's do. I'm not sure if this was proven in the work text. Hindi siya nakita during my last lecture, pero so I'll just write it down here. For any set A, for any set A and B, any sets A and B, A union B is the same as B union A. So this is what we call the commutative property. So commutative sa union. It doesn't matter sino yung una mong isulat dun sa union. Okay? Now the proof is straightforward, and it will take advantage of the connective OR used in the definition. So again, here we are tasked to show equality of two sets remember by ZF2 or the axiom of extensionality, the way to go with proving equality of two sets is to show that an element of the first set is an element of the second set and vice versa. Okay, that's what we're gonna do here. I will consider an element X of A union B. Okay, and then by definition, ito ay element ng X element of A or X element of B, right? That's what it takes to be in the union. So si X magiging element ng A union B kung si X ay element ni A or si X ay element ni B. Okay? And this is a biconditional statement kasi definition to ng ng union, pagiging member ng union. Okay? So just be careful pala when writing union and the connective. Minsan dito nalilito yung mga estudyante whenever they write the proof for the first couple of times. Okay? Now, a union, yung symbol na union, nire-require niya yung nasa kaliwa at nasa kanan niya ay sets. A union B. Si A at saka si B ay mga sets. Dun sa sumunod na line, ang ginamit ko ay connective na OR. Kapag connective na OR yung ginamit nyo, dapat yung nasa kaliwa at nasa kanan ay mga propositions. So, X element of A, that's a proposition because that's answerable by true or false. And X element of B is another proposition. So, for instance, you got confused with these two guys, tapos nilagyan nyo to ng union, mali na siya. Kasi ang union, ang kailangan mo sa kaliwa at sa kanan niya ay mga sets at hindi propositions. Okay? So I'll give minor deductions kapag ka medyo may mali dun sa language o dun sa grammar ng pagkakasulat nyo. I mean, mathematical grammar ng pagkakasulat nyo. Okay? And then remember that the connective OR is also commutative. So ibig sabihin, pwede rin ako ditong mag-if and only if uli kasi commutative law is a rule of equivalence. So this tells us that this is the same. X element of B or X element of A. Right? Kasi nga commutative yung OR. And then this guy is the very definition of being in the set B union A. All right? And what have we shown here? X is an element of A union B if and only if, puro series yan ng biconditionals, X is an element of B union A. Therefore, by the axiom of extensionality, we can conclude that A union B is equal to B union A. End of proof. Okay? So ito ay isang example ng biconditional proof. Hindi na natin kailangang hatiin sa dalawang piraso yung proof. Kasi all throughout the proof, we just use rules of equivalence. Wala tayong rule of inference na ginamit. Okay, so I hope that's clear. I think we have another nice result here. Theorem 6. It says that for any set A union the empty set is equal to A. Okay, so kapag ka nag-union daw tayo ng empty set sa kahit anong set, ang makukuha lang natin ay yung original set pabalik. Okay, so for that, let's try to prove it. Okay. Proof ng Theorem 2.6. Okay, so we want to show that A union the empty set is the set itself. Okay, so here I can start by assuming a generic element of A union the empty set. Okay, kasi pakita na siya ay element ng A. All right, so here I can apply the definition of the union. That means X is an element of A or X is an element of the empty set. Okay, however, we know that X element of empty set is false. Kasi nga ang empty set ay walang laman. So, from here, I can use a rule of inference para makonclude na X element of A. Ano nga yung tawag sa rule of inference na yon na ginamit ko? To get from the disjunction towards one of the disjuncts. Do you remember ano yung rule of inference? Ano yung tawag doon? Anyone? Oh yes, Perlene?
Disjunctive syllogism po.
Okay, that's perfect. Thank you, Perlene. Yeah, that's disjunctive syllogism. Alam ko na false yung pangalawa. Para maging true yung or, dapat sigurado tayo na true na yung una. So that's disjunctive syllogism. But the thing about the disjunctive syllogism, one way lang siya kasi rule of inference lamang siya. So from here, isang implication lang papunta kay X element of A. Wala yung kabilang arrow because hindi natin siya mako-conclude kagad mula doon. Okay? So therefore, all we can conclude here is that A union the empty set is a subset of A. Kasi meron tayong X element of A union the empty set implying X is an element of A. So yun yung very definition ng pagiging subset. All right? So that means we need to divide the proof into two parts. So for the next part, I'm going to assume a generic element of the set A. And the goal is to show that this is an element of A union the null set. Okay? Now, gagamit ako dito ng addition law, right? Pwede ako magdagdag ng naka-or kahit ano pa yan. It doesn't matter kung ano yung idadagdag ko. So this is by addition. And again, addition is a rule of inference. Kaya then lang yung ginamit ko, hindi if and only if. Alright? Kaya ito talaga, standalone, hindi standalone. Partial lang yung proof na makukuha natin if we start from X an element of A. Alright? But from here, from X element of A or X element of the empty set, we can say by definition of the union that X is an element of A union the null set. And so here we have shown that A is a subset of A union the null set. All right. Then look at our conclusions from the two parts of our proof. We got this guy and we got this other guy. All right. And then by the anti-symmetry property ng subset, di ba, nakita natin itong property ng subset last time, anti-symmetric siya kapag ka A subset ni B at saka B subset ni A, therefore A must be equal to B. Alright? Silang dalawa ay subset ng isa't isa, so therefore by the anti-symmetry, we can say that A union the empty set is equal to A. End of proof. Okay? So do you guys have some questions with the proof? Halata ba nagmamadali ako? Okay, so if there are no questions, let's see what's the next thing. Okay, Theorem 8 is a nice one, okay? For all sets A and B, if A is a subset of B, then A union B is equal to B. Nakita na natin tong scenario na to when we looked at Z union Q. Subset ni Z si Q, so nasubsume lang si Z dun sa union. Kasi nasa loob na siya ni Q in the first place, so wala na tayong ibang madadagdag. So yun yung observation natin kay Z at saka kay Q. And apparently, kung tanggalin ko yung pangalan na Q at saka Z, palitan ko ng A at saka si B, ang A pa rin ay subset ni B at makikita natin visually na yung union pa rin ay si B lamang. Alright? So A union B is equal to B, the larger set, because B already contains the elements of A. Bigyan na lang natin siya ng formal proof kasi dun sa diagram, madali siyang i-imagine. Nakapagpakita na rin tayo ng isang example kung saan siya nag-work. Kaya lang dun sa example na yon, pag kinalimutan natin na Z at Q yon, pinalitan ko ng A and B, nothing so special about them. A is still a subset of B, then the union is the larger set. Yun yung gusto nating ipakita sa Theorem 8. So let's try to write a proof here. Okay. So we assume A is a subset of B, and we want to show that A union B is just equal to B. Okay. So let's try to write the proof. Okay. Now, I will consider a generic element of the union. Okay. So that will imply, by definition, that X is in A or X is in B. All right. Definition ng pagiging nasa union. And then I want to show that X is an element of B, right? But remember that X is an element of A implies X is an element of B since A is a subset of B. pag si X ay element ni A, magfa-follow na siya ay element ni B. Alam na natin na si X ay element ni A. So by modus ponens, by affirming the precedent, we can conclude the consequent. All right? So by modus ponens, this statement here, okay, tawagin natin star, star becomes X element of B or X is an element of B. Kasi nga yung X element of A magfa-follow automatically na X element of B by the assumption that A is a subset of B. And then by the idempotent laws, X element of B or X element of B is just X element of B. So hence, we have shown that A union B is a subset of B. Okay? Now for the other direction, so I will let X be an element of capital B. Then by addition, okay, madali yung ano, no, yung pakabila. Kasi or lang naman yung kailangan ko, napakadaling magdagdag ng or. Kahit ano, pwede mong idagdag pagkatapos ng or. So you can say X element of B or X element of A. Then you use commutative laws to say that this is X in A or X is in B. And that means X is an element of A union B. So from merely assuming that X is in B, we're able to show that X is also in A union B. So therefore, we can say that B is a subset of A union B. But again, by the anti-symmetry of subsets, all right, nauna nating napakita, A union B ay subset ni B, and now we're saying that B is a subset of A union B. So we can conclude that A union B is equal to B, again, supposing that A is a subset of B. Okay? Halata ba nagmamadali ako sa discussion? But I hope you get the idea. It's just a play on the different rules that you have already learned before, hopefully, dun sa logic part. Nadagdagan lang ng objects yung pinaglalaruan natin. So, yung naka-or, pwede pala siyang tingnan sa union, and so on. So that's the concept of the union. And you will see I barely touch examples of taking the union. I hope that was already done in your prerequisite concepts. Kasi ang idea sa Math 101, ang ipuprove na ang mas focus natin ay pag-deduce at pag-prove ng mga properties ng mga operations at hindi lang simpleng pagpe-perform ng mga operations. Kaya yung pagte-take ng union sa mga specific sets, parang ano lang siya, para maintindihan natin yung definition. Pero aside from that, we'll be more working on the abstractions, meaning we will try to deduce properties of these set operations. So just let me know via the chat or you can raise your hand if you want more examples if the set operation is not clear to you bago tayo magpunta dun sa pagpo-prove ng mga properties nila. Okay? Because the examples here will be very limited. All right? Okay, so let's go to the next operation, and this is called the intersection of two sets. The intersection of sets A and B, denoted by A cap, para naman siyang cap, alright, na nakabaliktad, top hat or top cap. A intersection B, this is the set of all x's which belong to both A and B. And note that in its set builder notation, the connective now becomes an N. Alright, hindi na or. Kasi kailangan sa intersection, parehas silang nandun sa dalawang sets. Halimbawa, tingnan natin yung set of all letters sa salitang love. Tapos si set B, sabihin natin siya yung letters sa salitang hope. Yung A intersection B, sila yung mga elements na nakay A and at the same time ay nakay B rin. Okay? So in this particular case, si L ay nakay A pero wala siya kay B, so wala si L sa intersection. Si O ay nakay A, si O ay nakay B, so nandun siya sa intersection. Si V ay nakay A lang, wala siya kay B, so hindi siya kasali sa intersection. Si E ay nasa A, si E ay nasa B, so si E ay part ng intersection. All right? So if we will draw the Venn diagram to better picture how the intersection works, so halimbawa meron akong set A, tapos meron akong set B, okay? Lipat ko to dito sa loob, okay? So, dapat nasa parehong A and B siya. So, ibig sabihin yung intersection ay ito. Sila yung mga elements na nakay A na at nakay B pa. Sorry, lampas yung pagkakakulay, pero I hope you get the picture. This element X here, say here, it's not in the intersection because it is only in A. The element Y is not in the intersection because it is only in B and not in A. Z is in the intersection because it is both in A and B. The element little v is not in the intersection because it is neither in A nor in B. All right, so dapat nakay A at nakay B rin siya. Okay? Now, another illustration for the sake of infinite sets, we let P be the set of all prime numbers, E plus be the set of all even positive integers, and their intersection will be just the singleton, the set containing 2. All right? So kapag ka isa lang pala yung laman ng set, ang tawag natin doon ay singleton. Okay? Isa lang yung laman. All right? Kasi nag-iisa lang yung prime number na even din. Si 2 lang yon. Okay? Now, siguro a quick rapid fire recitation. So raise your hands if you want to answer. What is our intersection Q? Go. Sinong nauna? Halos sabay. So, Crizel. Sige, sunod si Axel. Crizel, our intersection Q?
Q po.
Thank you, that's right. Axel, you want to try B? Q intersection Z?
Z po.
Okay, great. Z intersection R. Later ka na ulit, Perlene. Who else? Sige, walang nasagot, Perlene. Z intersection R?
Z po.
Okay, great. How about Z intersection the empty set? John Raphael? Okay, empty set. Thank you, John Raphael. What's your nickname, JR ba or Raphael? So just let me know. Okay, empty set. All right. And then the last example is quite interesting. Kasi kapag ka si Z, okay, JR, kapag ka si Z, kapag ka kahit anong set, in-intersect natin sa empty set, dapat parehas nila dapat laman, di ba? So, nakita natin dito empty, walang laman yung intersection nila. And true enough, Theorem 14, medyo nakita na natin, spoiler yung Theorem 14, sinasabi niya na kapag ka nag-intersect ka ng empty set sa kahit anong set, ang laging sagot ay empty set. And intuitively, it makes sense kasi dapat common na nandun sa una at saka pangalawang set, walang laman yung pangalawang set. So yung intersection dapat walang laman. But it could be a little bit of a challenge to provide a formal proof for that statement. Okay? Pero let's try pa rin. Okay. So here we want to show that for any set A intersection the empty set is the empty set. Okay? Now, it is a usual technique that in showing that a set is empty, we'll use a proof by contradiction. We will assume that it is not empty and then draw up a contradiction from it. So that's my strategy here. I will suppose, for the sake of contradiction, that A intersection the empty set is not empty. Kunwari may laman. At tawagin ko yung laman na yon na X. Okay? Kasi nga, inassume ko na meron siyang laman, kunwari si X yung laman niya. Then I'm going to use the definition of the intersection. That means X is an element of A and X is an element of the empty set. All right? And then I'll use simplification. Kunin ko yung pangalawang conjunct. Kasi ito yung interesting. It is saying that X must belong to the empty set. But that is a contradiction. Dahil nga yung empty set ay walang laman. So paano siya nagkaroon ng laman na X? Alright? That should be absurd. That is impossible. That is crazy. So we don't want to accept that. So therefore, we will be forced to accept that A intersection the empty set is the empty set. Okay? And the proof. So yeah. Oh, by the way, another terminology that I would like to add, I'm not sure if it is mentioned in the work text, but if A intersection B is empty, then we say A is disjoint from B. Okay? Or we can also say that A and B are disjoint pag wala silang intersection. Okay? And that term is actually inspired by the Venn diagram. So ito yung example na si A at saka si B, empty yung intersection. Di sila nag-overlap. And you can think of them as being disjoint or not connected from each other. All right? Para mas madali niyo siyang matandaan. And then I guess, of course, marami pang properties yung mga intersection, yung union saka intersection. We are just going through some of them. Kasi yung iba, we will trust that you can prove them. Binigyan lang namin kayo ng example paano usually nag-work yung proofs for union and intersection. Okay? May isa pa pala na magandang theorem about intersection. So tingnan natin kung ano yung nangyayari kapag ka yung isang set ay nasa loob ng isa pang set. Halimbawa si set A ay subset ni set B. Nasaan yung intersection nila? Anyone? Ano yung intersection ng A at saka B? Yes, Tricia?
A.
Okay, thank you. That's perfect. Si A. Kasi si A ay na kay A, tapos si A ay na kay B din, so dapat ang intersection nila ay si A. So sa union, okay, kung meron kang A subset of B, yung union nila ay yung mas malaking set, yung superset. Pero yung intersection nila ay yung mas maliit, yung subset. Okay? Now let's prove that. Dito na lang sa kabilang side. All right? Okay. So we assume that A is a subset of B, and we want to show that A intersection B is the subset. All right? Yung mas maliit na set dun sa dalawa. Okay. Let's try to do it. Okay. One implying the other. So I will consider an X being in A intersection B. All right. By definition, that means X is in A and X is in B. Definition ng intersection. I want to show that X is also in A, so I'll use simplification here. Pag and yung connective, pwede lang nating basta-basta tanggalin yung isang conjunct. Kasi para maging true yung and, dapat totoo sila parehas. So this should be true, this should be true. So I get one of them, I'm sure that that is true. And that is what we call simplification, one of the rules of inference. But hindi to pwedeng maging biconditional. Kasi pag nagsimula ka sa X element of A, hindi natin alam kung true pa rin ito. Okay? So that means we really only have a one-way implication here. But at least we have shown that A intersection B is a subset of A. In fact, ang intersection ng dalawang set ay subset nung parehas na set. Okay, A intersection B is a subset of A, and it is also a subset of B. And the proof will just require simplification, just as like what we did here. Okay. The more challenging one, I guess, is hindi naman masyadong ka-challenging, but now let's consider an X an element of A. And we want to show that this is also in the intersection. All right. Now, if X is an element of A, then it will follow that X is an element of B as well, since A is a subset of B. Definition ng pagiging subset, X element of A implies X element of B. We are assuming that X is in A. So it will follow that X is an element of B. Kasi again, si A ay subset ni B. Tama? And then now, I have X element of A. All right. And X element of B by conjunction. I know this is true by assumption. I know this is true because it directly follows by the definition from the assumption. So true rin siya. So I can put them inside an N. All right? Kasi parehas silang true, i-conjunction ko sila, alam ko na true yung makukuha ko. All right? And this is the very definition of being in the intersection. All right? So therefore, we have shown that A is a subset of A intersection B using the assumption that A is a subset of B. And then again, now I can appeal to the anti-symmetry property or the anti-symmetry of subsets. Si A intersection B a subset ni A, pero si A subset ni A intersection B. So by anti-symmetry, we can say that A intersection B is equal to A, end of proof. All right. Do you guys feel confident about proving statements about union and intersection? Okay lang ba? At least you get the feeling how it is done. Kung mapapansin nyo, lagi lang akong bumabalik dun sa definition ng union at saka intersection and applying yung mga properties dun mula sa logic na natutunan natin. Okay? Don't worry if you don't remember all those terms before. Hindi nyo naman kailangang isulat dito na gumamit ako ng modus ponens, gumamit ako ng modus tollens, gumamit ako ng disjunctive syllogism. As long as you know the form, that's fine. The nomenclature is just a formality. Binanggit ko lang din siya para makita nyo na yung mga pinag-aralan natin ng chapter 1 ay nag-hold pa rin or nagagamit pa rin sa chapter na to. Okay? So, any questions about the intersection? None? And then, okay, so if so, I'll finish off with the third operation, which is the set difference, okay? And that's in definition 18. The difference of two sets A and B, denoted by A minus B. However, kapag ka ako yung nagsusulat by hand, ang sinusulat ko ay ganito. Oops, sorry. A minus B. Backslash yung ginagamit ko, hindi horizontal na minus, all right? Just a force of habit. So whenever I have something handwritten, I write the set difference this way. So what's the requirement to be in the set difference, okay? Para mag-belong ka sa A minus B, dapat na kay A ka, pero wala ka kay B. So you can imagine the set difference to be choosing elements of A that are not in B. So parang nagsimula ka kay set A. Sila yung mga candidates para pagpilian mo para matira dun sa set difference, okay? Pero yung final answer ay tatanggalin mo mula kay A lahat ng na kay B. Yun yung set difference. So in Venn diagrams, bawa ito si A, ito si B, candidates natin para sa set difference, yung mga elements ni A. Pero mula dun sa pool of candidates na yon, tatanggalin ko yung mga na kay B. Alright, so tatanggalin ko lahat ng nasa loob ng rectangle. Alright, and so matatanggal to, matitira lamang ay yung mga members na kay A pero wala kay B. And this yellow shaded region here is the set difference A minus B. Okay? So I hope that makes sense. Now to illustrate that, let's look at example 20. So again, si set A, yung first four prime numbers, si B, yung first four positive even integers. If we compute for A and B, if we compute for A minus B, ang candidates natin ay nanggagaling kay A. Pero tatanggalin ko mula kay A kasi A minus B yung kinocompute ko, tatanggalin ko lahat ng mga members ni B. So si 2 ay na kay B, so matatanggal si A mula dun sa set difference. Si 4, tatanggalin ko, oops, wala naman akong 4 kay A. Tatanggalin ko dapat si 6, oops, wala rin akong 6. Si 8, tatanggalin ko, wala naman akong 8. Alright? So that means the set A minus B is just the set containing 3, 5, and 7. Okay. On the other hand, if you're gonna compute B minus A, so laging yung minuend, yung nauunang set, sila yung pool of candidates. So dito ako kay B magfo-focus. Tatanggalin ko lahat ng mga elements ni B na makikita ko mula kay set A. Meron akong 2 kay set A, so tanggal si 2 mula sa set difference. Meron akong 3 kay set A, but luckily wala namang 3 kay set B, so it won't affect the set difference. Si 5 at saka si 7, wala rin siya kay set B, so wala nang ibang matatanggal. So si B minus A ay set containing 4, 6, 8. And this example tells us na hindi pala commutative ang set difference unlike the union and the intersection. Because here we have a counterexample. We have two sets A and B na yung set A minus B ay kakaiba mula sa set B minus A. So in general, A minus B is not the same as B minus A. So walang commutative property ang set difference. Okay? So I'm a little bit running off time. Sorry, sabi ko. I am running out of time. So, bilisan kong sagutan tong A minus B. Sabihin nyo lang kung may mali. Double check nyo na lang later, alright? Ang A minus B natin ay set containing 2 and set containing 2 lang. Sorry, 1 and 2. Tama ba, guys? Just call my attention kung may mali akong masusulat. Si B minus A naman ay 5, 6, 7. Tama ba? Okay, hopefully tama pa yung set difference ko. Oh, yun lang naman pala. How about A minus 0? Or sorry, A minus 0. A minus the empty set. Or in general, sige. Set C minus the empty set. Where C is any set. Oh yes, Prince. What do you think is the answer here? C minus the empty set. Okay, great. That's correct, Prince. C. Kasi ang candidates mo ay lahat ng nakay C. Tatanggalin ko lahat ng elements ng empty set. Pero yung empty set, wala naman siyang laman, so walang matatanggal. Safe lahat ng elements ni C. So ang matitira pa rin ay set containing C. Okay? How about the empty set minus C? Where C is any set. Can anybody tell me what the set difference is? Yes, Perlene?
Empty set po.
Okay, great. Empty set. So, minsan nalilito yung mga estudyante, akala nila cannot be. Pwede yan. Ang mga candidates mo nga lang ay yung mga laman ni empty set. Eh, walang laman si empty set. So, kahit anong gusto kong bawasin sa kanya, will not remove the fact that the pool of candidates is empty in the first place. So, it's impossible to have a non-empty set difference. So, ang empty set ang set difference sila. Okay. Now, ito siguro. Can you guys give me some cases or scenarios when A minus B is the same as B minus A? Can you think of some special cases na merong sort of commutative property? But just to clarify, hindi commutative ang set difference kasi hindi nag-work, hindi laging equal yung A minus B at saka B minus A. Pero there could be some special cases na sila ay maging equal sa kanila. Sige nga, JR, magbigay ka ng example. Kailan kaya pwedeng maging equal yan? Okay, sabi ni JR, kapag ka si A ay equal kay B. All right, I think that is, I think that is correct. Kapag ka si A at saka ay equal kay B, yung A minus B ay empty, yung B minus A ay empty rin. So good, that's one scenario. Ano pa ba? Okay, I think that's the only case. Meron pa ba akong nakalimutan? Yes, Crisel, you want to add something?
Sir, what if po A and B ay empty set?
Okay, posible rin. Kapag ka si A at saka si B ay parehas empty. All right, that's a good example. Kaya lang covered na yun ng statement ni JR, but nevertheless, good one, Purcell. I think, yun nga lang ba? Sige, pag-isipan pa natin kung yun lang. Medyo napaisip ako kung yun lang yung posibleng case. I think, what do you want to say, JR? I think you want to say that A is disjoint from B. Walang common elements sa si A at saka si B. But I don't think that will make the set difference equal to each other. Kasi kung disjoint, actually yun yung next uh, icebreaker ko supposedly. Kapag ka si A at saka si B ay disjoint, alright, wala silang intersection. So yung A minus B, ano sa tingin niyo yung A minus B? Kung disjoint si A at saka si B. Ano yung A minus B? Yes, Trisha? Okay, siya lamang ay si A. Kasi nga, ang candidates natin ay puro mga nanggagaling kay A. Tatanggalin ko lang sa kanya yung mga elements ni B. Pero sabi daw, walang common elements si A at saka si B. So yung pagtatanggal ng mga elements ni B ay walang epekto kay A. Kasi wala namang elements si A na kay B. So ma-retain lang ay si A. And similarly, B minus A will also be, ano susulat ko? Will be B. Tama? So ang B minus A ay equal kay B. Kasi nga, again, tatanggalin ko mula kay B lahat ng na kay A, disjoint nga si A at saka si B. So yung pagtanggal ng elements ni A ay walang epekto kay B because they don't share any common elements, so walang matatanggal mula kay B. So ito, si A at saka si B, hindi sila equal sa isa't isa kasi nga disjoint sila. Okay, so that means, hindi equal yung A minus B at saka B minus A kung sila ay disjoint. Pero ang icebreaker ko sana, dito ay kailan ang A minus B ay equal kay A. So one possible answer is that when B is the empty set, all right? But the more generic answer is that if A and B are disjoint from each other. Okay? Let me see if I'm done. Okay, I think that's a good time to stop. Sorry, I'm 4 minutes late in dismissing you. Pero pa-weekend na naman, so I think you don't mind staying 4 minutes longer. So do you guys have any questions? Sorry, medyo feeling ko mabilis, pero I hope you still got the idea. Di ko alam, nababagalan ba kayo sa pagsasalita ko minsan? Kasi I am sometimes watching my recordings and it seems na minsan ang bagal ko magsalita. Kailangan kong i-times 1.5 para normal speaking speed. Because tendency ko yon kapag hindi ko sure kung naiintindihan ako or naiintindihan yung dinidiscuss ko, masyado akong mabagal magsalita pag ganun. Especially sa online setting because I don't see your faces or your reactions. But let me know if that is too slow. I'll try to speak faster. Pero feeling ko ang bilis ko magsalita today. So I hope you still got the gist of the topic today. But with that, again, I'm inviting you to attend the lab classes on Monday. I already told your lab instructors that I will count on them to finish the rest of this module. So, didiscuss nyo sa Monday yung set complement hanggang sa Cartesian product. Okay, it might be too long, pero probably it will take them 1.5 to 2 hours. So kindly bear with them. Mahaba naman yung discussion para lang makausad tayo sa susunod na module. Ayoko naman na sige, i-discuss ko lang ay hanggang set complement tapos reading assignment na yung cross product. Gusto ko nandito pa rin kami para i-guide kayo. Okay? So, any parting thoughts, parting words for this week? Any questions, appeals, requests? All right. So if there are none, then thank you guys for sticking around. Enjoy your weekends, and then let's see each other again on Wednesday. Bye, everyone.